Now, I want to do this together, but I want to maybe make you guys do a little bit more of it. You're going to write down the original nth term, 2 to the n over 3 to the n plus 1, and I want to see if you guys can come up with the thing to compare it to. And then also put it on the appropriate side. Is the thing you're comparing to going to be bigger than the original formula I have written down, or smaller than? Is it going to be on the left of it or on the right of it? So take 30 seconds to do that. So what are you going to do to make this formula simpler? Remove the plus 1. Okay, so that would leave you with 2 to the n over 3 to the n. Does that go to the right of the original nth term or to the left? To the right. So you're saying 2 to the n over 3 to the n, when you delete the 1, that's bigger? Yeah, why? Because it makes the denominator of the original guy smaller. Make the denominator smaller, the overall number is bigger. And then they're both bigger than 0. So there's technically strict inequalities, but again, if you put less than or less than or equal to, I don't care. Now, the only time I do care is if it could equal 0 and you use a strict inequality, right? Then I might say something, but it won't be much. Everybody believe that? Now, could you write 2 to the n over 3 to the n in another form that could be helpful? So what does that equal? Why is that form helpful? Because then you can see that's a geometric sequence formula. You put a sum in front of it, it's a geometric series. And you know what geometric series do. So what's the series in the next step? Sum n equals 0 to infinity of 2/3 to the n. What's your conclusion about that guy? Converges, and yeah, we should say it's a geometric. Although I suppose if you write down r is equal to 2/3, which is between -1 and 1, I'll know that you know it's geometric, but humor me on that one. Okay, so that's the reasoning, and then, well, okay, then if the sum, so here's the reasoning, you guys. If the sum involving this guy converges, then certainly the sum of something smaller of smaller numbers converges, right? So these are actually a bunch of numbers, right? If the sum of those numbers converge, then the sum of these numbers must converge because they're smaller. Each individual one is smaller. I really like this test because it's common sense put in math notation. So the original series sum n equals 0 to infinity 2 to the n over 3 to the n plus 1 converges by the comparison test. Okay, so notice in these three examples, we compared the given series essentially with either a p-series in parts A and B, or in this one, a geometric series. Why? Because we know what those series do, and we can get convergence or divergence from a p-series or a geometric series immediately. So that's why we try to compare to those series.